Hello, hello, hello. I don't have a title yet for this podcast, but it's my first attempt with our fine guests here today. My channel on YouTube is called Love Digenous, so I'll probably add something after the colon, Love Digenous and genomics discussions or something. But right now we're going to start. Oh, it says my connection is unstable.
You glitched a second there, Joe, but you're back.
Let me see. I'm going to close these windows, see if that helps. Okay. We are going to talk about Professor Tabery and Professor Raff's books that came out not too long ago, and then have whatever updates they can give us about the data landscape or the ethics landscape, and then we'll move on to discussion about specific topics that Indigenous people are concerned about. So, with that, Dr. Raff.
Sorry, you
Still
glitched
glitching a
again,
bit,
Joe.
Joe.
Sorry. Do you want me to go ahead and start?
Yes, please.
Okay. Hi, I'm Dr. Jennifer Raff. I am a anthropological geneticist at the University of Kansas, and I am really interested in looking at the histories of Indigenous peoples, trying to understand the landscape of um, Indigenous histories, genomic histories, context of understanding it with an eye towards ethical approaches and being critical and self-critical about our disciplines and our histories, past and current efforts at colonization and doing this work in ways which can be quite harmful. A lot of my work is spent interfacing with the public. I do a lot of public speaking and writing in order to sort of bring the issues and the stories from my discipline to the general public. And that includes my first book, Origin, A Genetic History of the Americas. And I'm currently working on my second book, which is about human evolution.
Thank you. Dr. Tabery?
Sure. I'm happy to be here with you, Joe and Jennifer. I've been looking forward to this conversation. My name's Jim Tabery. I'm a professor in the philosophy department at the University of Utah. The book that Joe mentioned is called Tyranny of the Gene, Personalized Medicine and Its Threat to Public Health, and that was published back in 2023. The basic thesis of the book is that for the last 15 or 20 years, healthcare, particularly in the United States, but we're seeing it more generally, has been sort of accelerating at a faster and faster pace towards relying more and more on genomics, while ironically at the same time, we keep learning more and more about genomics and how little it contributes to actual differences in health outcomes generally, and particularly with regards to health disparities among populations. Um, so fast forward 3 years later to the present, I think actually we've seen both trends continue. So on the accelerating faster and faster, that has certainly continued to happen. Companies like Illumina, Regeneron, universities are investing more and more in just trying to get as much genomic data from people as possible. You're seeing pushes now to get it from every newborn who's born in the United States, kids going to school, people trying to access Medicare and Medicaid. So there is this sort of increasing expansion of trying to get as much DNA as possible. And on the flip side, I think the more we've learned about genomics, the more there's reason to be skeptical that this is actually going to actually produce substantive impact on health outcomes. One, I would say just a sort of a classic example of it is, since I published the book 23andMe has gone bankrupt. And 23andMe is in some sense sort of like the embodiment of the vision for personalized medicine. It came on the scene in 2007. It was built on this vision of everybody's going to get their own genomic information, and then they're going to be able to take ownership of, direct, be healthier, healthcare. And that just didn't happen, right? In fact, the company is now, essentially non-existent, and I think that's really indicative of this kind of this pivot more generally. One of the things I'm most excited to talk about with both of you today is the sort of similarities and differences between the trends that we're seeing. And on the one hand, the role of genomics in archaeology and aDNA research, and then in biomedicine on the other side, because I think there are kind of interesting overlaps between the ethical issues that arise, the relationships between researchers and participants, the dynamics of who benefits and who doesn't. And I'm looking forward to learning from you.
So I'll introduce myself. I'm Joseph Shetta. I am of Purépecha descent from Mexico, but I live and work on the Cheyenne River Sioux Reservation, where my wife and kids are enrolled, and is the home of the Native Biodata Consortium. So we're a 501(c)(3) nonprofit. We began in 2018 with a South Dakota business license. We got our IRS standing in 2019. We are registered with the tribe as a business, and like it or not, COVID was really a boon to indigenous people all over the place. And there's plenty of stories in Ecuador and Peru and Bolivia, and of course here in the States and Canada, where natives really got to push their issues forward based on the inequities and slow responses from different governments to indigenous peoples. So we were one of those beneficiaries. We received lots and lots of funding, and we've moved up through the NIH and other places like MacArthur Foundation in terms of our esteem. So I'm going to ask Dr. Raff. So in addition to the update that you gave us, is there something new that you're seeing either happening right now or on the horizon in genetic anthropology and archaeology in terms of data sharing? Because a lot of the open data policies, which in the United States began in 2013 with the national academies, is now sort of being closed because of some of the edicts and moves by this administration. Specifically, the Department of Justice says that anything with more than 1,000 samples that has biometric data, and they're having biometric like widely defined, has to be controlled by Homeland Security. So there's all these different changes and definitions and things like that in terms of what belongs to the United States, especially as Dr. Tabery mentioned, 23andMe, the sale was stopped. Regeneron was not allowed to buy it because the senator from Illinois, Dick Durbin, said that was in violation of the 2022 version of the American Competes Act. So has there been much talk about all of this stuff?
Not about those things specifically. What's on everybody's minds these days is AI and the sort of infiltration of AI into all academic spaces. I'm thinking of it primarily from a teaching perspective, which is very complicated, but a lot of my colleagues are discussing the uses of AI for research. There are pros, there are cons. I am not a data person, an analyst, so I don't really use it. I definitely do not use it for writing. That's horrific. But I know some colleagues who are using it productively in the sort of data analysis space. I also know people quite nervous, though, about the application of AI to indigenous genomes specifically and data privacy in general. And so I'm just kind of learning right now because I am, as I said, not a computer person, not an analytical person as far as that goes. And so I'm trying to get a grasp on where this is going and, how can we add our own influences to try to steer it in the better direction than it could be going. But I have to admit that I'm pretty ignorant right now about all of it. So I'm doing my best to master this landscape, and it's not easy at all. The other thing that I'm hearing a lot about, well, the other thing that we're all talking about is, of course, the major thing that has changed is the administration. And the political landscape is bleak right now. And it is really causing people to rethink their practices, as I think you alluded to, and also kind of to hunker down if they can to try to wait this out and hope that we'll have a more science funding in the future. But it's just really horrific watching grant after grant many of them going to very good projects that are designed to explicitly to benefit different communities, just watching them get killed just at the whim of Doge. And so we're still trying to figure out how can we strive for some equity and some justice in the world, in the world of science and anthropological genetics in particular, when we have all of this arrayed against us.
So, what I liked about your book is that you did a comprehensive telling from Alaska to the tip of South America, right? And in that regard, I see how open data is necessary, like to try and piece that story together. And forgive me if I'm wrong, but the stakes for what you do is a lot lower than for biomedical health, right? Like you're trying to save people's lives with that, and you're trying to develop pharmaceutics and interventions and all that kind of stuff. So in that sort of binary, how do you feel about open data generally? Because the data that you use and other people use is across many governmental jurisdictions, and they don't all have the same opinion. You know, Latin America and Anglo America are different. United States and Canada are different. Bolivia and other Latin American countries are very different because Bolivia is an indigenously controlled country, and other countries are not. So, like, what do you feel about open data in your field particularly?
I think there's a lot of tension between the positives and the negatives of open data. So there are some benefits to having data freely accessible, especially to people from underserved communities who might want to use it for their own research, for small lab groups who really could not generate the data, the giant data sets that some of the big labs can. And I think that we all hear about the benefits of open data quite a bit. So I don't think I really need to articulate that. I certainly have benefited from open data for sure. A lot of our research makes use of comparative genomic sequences that are freely available to us. But there's tension because, of course, in this current era and even in the previous era, um, there are people and organizations and institutions and sovereign nations who really have some major qualms about data being freely accessible. They have no control over what is being done with that data. They have no control about whether or not it will benefit or harm their citizens and or members. And so I really am leery about that. And when I talk to people about this issue, I try to just lay out both and say both the pros and the cons and say, hey, this is something you need to be thinking about. But every group, every sovereign entity needs to be making their own decision about this, but they need to be making it in an informed way. And so I'm just trying to do what I can to contribute to that information, and to make sure that at least my small lab group are scrupulously following the wishes of whatever group we are working with, and making sure that there's a place for them to change their minds if they wish, and that this is sort of an ongoing dialogue.
So the same question to you, Dr. Tabery, since you published your book. Landscape changed. We had the ABC study that is making everybody nervous because they used that study, that 20 years worth of data, to basically say African American children are less intelligent than European American children. We had the 23andMe sale that we were talking about. We also had the UK biobank that got hacked and on the market on a platform for sale in China. And then the Assembly of First Nations in Canada voted in Resolution 11, which said Canada has to stop collecting human DNA for their precision health initiatives. So, like all of these things, including the de-siloing of other kinds of data like archaeological or anthropological genetics is happening now.
Yeah, I think a little bit of history is helpful here because we've lived in this world of open uh, access to the data and genomic data for so long. You almost kind of take it for granted and assume there couldn't have been another way. But in fact, some very specific decisions were made decades ago that set us along this path and created this environment now that we all live in. So, part of it was fear of commercialization and patenting, and right, and thought was sort of like, if you just sort of force everybody to put their DNA into these open systems, then it prevents people from patenting genes. It becomes this common good that everybody's able to benefit from. I think it was also designed to stoke this collaborative ethos of, we're going to be transparent. There's something uh, universally human about DNA. And so when you gather it, you put into these public spaces that other people have access to. Um, you know, Ironically, I think those efforts didn't even sort of curtail the concerns that they were worried about, because private industry has controlled so much of genomics on the biomedical side significantly anyway. They didn't have to patent genes to charge millions of dollars for gene therapies. They didn't have to patent genes to charge hundreds of thousands of dollars for gene-targeted cancer drugs. And so the sort of the cost issue is still there. But now what you do have is this way in which the bar for getting access to this data is quite low. And I think, as Jennifer mentioned, there are real upsides to having that bar low. And so I think if you're thinking about how do we offset that by raising it, you're going to have to contend with what the costs of that are and the impacts on the researchers. But we're clearly, I think, we should just sort of say, if you sort of were imagining the realm of possibilities in terms of access to data by the research community, we're at one end of the spectrum, and that is sort of has a very low bar for access, and then has very high risk for people doing all sorts of things with it that maybe original participants weren't thinking about or consenting to. When you see that, when that happens on an isolated case, or I think of something like the Havasupai case, where it's one research organization, one community, they're giving their data, they think to sort of help combat a diabetes epidemic in their community, only to learn years later, right, it's actually being used to trace things like human migration, inbreeding, mental health issues. There, the relationship was very sort of, it was clear who was at fault and who was suffering as a result of it and how to redress that problem. But now when you're just putting all this data from lots of different sources into one place where people can then go and access to, the threads of responsibility and ownership and who sort of consented to what become quite nebulous. And so I think that's what makes it hard to govern this now.
Yeah, it's interesting because of after both breaches, the one for the ABC study and the UK Biobank, a lot of the non-native researchers at NSF and NIH feel like we feel, because the 1,200-pound gorilla isn't just in the cage with us; it's now in the cage with them, and they're balking, and so they, some of the ideas that Native Bio had a while ago about watermarking data or barcoding the data attached to the researcher is now something that these U.S. university researchers are considering, right? Because
So you can keep those threads.
yeah, but
Yeah.
now the researchers are pushing back. They're like, I don't want to be held accountable for something
Mm,
one of my graduate students does, or that something leaks to one of our private partners, like
mm,
the university in this case, because the university, through the Bayh-Dole Act, has ownership of the data, or at least the first licensing rights of the data. So the university should take some of that liability instead of putting all of the onus only on the researcher. You guys would be on the hook, and it's not like you guys are rich and you can defend yourselves in a court of law, but you guys would be on the hook for that rather than the university or any of their policies. And so
mm.
this is kind of the debate that we've been in, or Native Bio's been in. So we're part of large projects with the NIH, these multi-million dollar ones. And so people are really scrambling to try to find a solution. And I think everybody agrees it's like making the researcher the fall guy is not the solution.
Mm.
I think we all agree on that. That's
Yeah. I have a question to both you, but I'll ask Jim first. I have my own opinions about why indigenous populations are so interesting, but why do you think indigenous populations are so interesting, both to public and private data collectors?
Yeah. So what's the inherent value that makes them attractive to people to try to get access to the data?
Yeah,
So I think,
let me tell you
yeah.
one little story. So my wife she's enrolled with the tribe. A researcher came and said, "There's nothing special about you. Like if it were me, I would give my data all day long and it would not hurt me." And so you can give it, don't give it, it's not a big deal. So my wife said, then if we're not that special, then why do you keep trying to come back over and over and over again to tribes to get their DNA?
Yeah. Yeah, I mean, I think it's not just indigenous communities, though I think a lot of the focus has been there. You're seeing this happen all across the world. Uh, Geneticists are interested in isolated populations because when you get isolated populations, interesting things happen genomically over time, and as a result, sort of each isolated population is kind of its own natural experiment where you can see what has happened and then how does that impact, in the case of biomedicine, health outcomes. And so whether you've got researchers right studying a kind of a Black community in Dallas or an indigenous community in Australia or Indonesia or the United States, really what they're looking for are essentially genetic oddities, something interesting happening that shows kind of what the genome is capable of that they weren't seeing when they were looking at the other databases that they already had access to. And that might be in the form of, oh, look, you've got this population or a subgroup that's eating just like everybody else is eating, and yet everybody else has very high cholesterol and they have very low cholesterol. Let's figure out what's going on with this subgroup that has the very low cholesterol, despite the fact that everything around seems similar to everything else. And then the thought is you might be able to sort of find the genetic cause. That gives you a drug target. Now suddenly you've got a new cholesterol drug. And so largely what you're doing is sort of seeing genetic researchers drawn to what are sort of, again, kind of potential genetic oddities that are going to be insightful for then finding new ways to intervene in the world pharmaceutically. What's particularly worrisome about that is typically the recruitment and engagement arm of that looks like, hey, your community is suffering from these terrible health disparities. We want to help you with that. Give us your data, and then we can combat this thing that you and your loved ones are suffering from. Like, this is exactly what happened with the Havasupai and diabetes. But then that's the promise. What they end up getting is looking for drug targets that might have nothing at all to do with the actual health disparities that are impacting that community. And so there's this kind of disconnect between the sales pitch to the communities and actually what is likely to come out of that research, if anything at all.
Dr. Ralph?
Yeah, I agree that it is rare genetic variants are what geneticists are interested in. And so, and those come about because of unique population histories. I think anthropologists are also really keenly interested, not just anthropologists, but lots of researchers are keenly interested in the histories themselves. I mean, I certainly am. That's been my focus. I'm not at all medically inclined. And the Americas and the populations across the Americas, the indigenous populations across the Americas have these wonderful, fascinating, complex histories that just people find really, really, really fascinating. And that could be a good thing. It can be a bad thing, right? I think where it starts being a bad thing from a cultural perspective is where non-native people start then trying to appropriate that history or insert themselves into it. And, I think appreciation is one thing, but trying to colonize that history for our own purposes, that's another thing. And so trying to make sure that this is not the outcome of telling, these stories and learning about this history. That's, so something that has to be at the forefront of all researchers' minds, I think. But I do think that my colleagues who do more medically oriented research would say, well, we don't know what's out there until we actually go and look for it. And we can't assume that, we're going to find one thing versus another. We need to be looking at data on a big scale in order to see anything, even the small things, and to find any of these rare genetic variants that might actually be involved in important drug targeting. It might actually be important targets for drugs. I think though it's going to take some time, and I really hope that the work that you're doing, Joe, to raise these concerns among scientists and medically oriented researchers really will have an effect because I think that there's so much optimism that sometimes it blinds people to the downsides of
Hmm.
open data.
So, Dr. Raff, do you do your own biostatistics?
No, I don't. I work with people who do them. So
Oh, okay. Well, I wanted to go over a few concepts for the audience because both of you had mentioned big data and these assumptions about populations, but what we think is missing is number one, small data statistics, because not only are there many bottlenecks over the thousands of years for our people, but there's a genetic drift and a whole bunch of other things that make the analysis of hemispheric wide data complicated, right? We have bias references, we have ascertainment bias, we have like lots of these biases, and then on top of that, you do a statistic that was not that's general population biology that's not made for these sort of little mosaic island populations all over the Americas. So I just wondered if you wanted to speak to any of that.
Oh, I'm the worst person to speak to analytical methods, I'm afraid. It's very
Yeah.
embarrassing, but I came of age in an era that was pre-genomics. And so
Yeah.
I did not learn all the methods, and it's really showing now when I have students who are trying to explain this stuff to me. On the, I will just say that you're right that there are real ascertainment biases, and that we have to really think carefully about um, what kinds of analyses we're doing and how we're doing them, because what you use for a reference makes a huge difference. I definitely see this in my own work. And it's something really that anybody who's working with Indigenous data needs to be mindful of and needs to be very careful about. And I think they are, but I don't know if that's universal.
Well, like from your book, I've been in social media spaces and people cite your book a lot and even the timeline, the estimates for how long we've been here have changed quite a bit. The Beringia pause, that's changed, right? And that's based on new data, right?
Yeah, yeah. Well, and it changes in many different directions, right? So now there's this is the questioning about whether Monteverde, the site of Monteverde in Chile, is actually legitimately pre-Clovis, legitimately old. And we are right now having this big discussion in the field about how that will not change the genetics results that show that indigenous peoples, whether or not Monteverde is pre-Clovis, makes no difference to the genetic models, which are all estimating a much earlier coalescence of populations. So that is kind of all of the latest discussions that are going on right now.
So we have a common group of people called the Summer Internship for Indigenous People in Genomics, right? And we've both been faculty,
I love
and
them.
and Ripon Mahi from University of Illinois is part of that group, and so he and I discussed about how you do these hemispheric wide associations, and Eski Villerslev and David Reich have done their own analyses. And the general principle is that you're comparing modern populations who have grandparents and great grandparents in the one area, right, to these ancient samples that are across a large landscape. And so, because you're doing these multiple cross-referencing analyses, you could say that the populations from Alaska to the tip of South America share some common heritage, right?
Mhm.
But then other people, especially people from the Southeast United States and a few other places, say, but there's huge gaps in the data collection, right? And not
Mhm.
all data is open, especially here in the United States, not all data is open for tribes. So, given that critique, how could be our current understanding about the relationship between people of North, Central, and South America change if we have more data?
That is a very good question. So keep in mind that every individual genome is not just a single data point. And sometimes I have to, butt heads with archaeologists a little bit about this because the scales of our data are very, very different. Finding a particular projectile point of a particular style at one site is just one site, right? But that's not the same thing as a single genome. A single genome literally contains thousands of individual histories of individual ancestors present across the genome, if you can get the whole genome. So it's not just one piece of data, it's many, 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 many pieces of data. So one genome can be used to reconstruct a lot of population history, a lot. That being said, it's not all, and definitely the more refined and the more finely grained we sample populations and we understand the genetic variation, we're starting to uncover more genetic variants. And looking at history, we get some unexpected findings that were not detectable in previous eras when we were just looking at mitochondrial data, which is maternally inherited, or just looking at Y chromosome data, right? Those are just single parts of the genome, single points of history. And so it really matters that we have more genetic variation that we sampled across time and across space in order to make sure that we have the most accurate models of population history. And there are indeed some huge gaps, particularly in the United States, particularly in South America. But again, that has to be balanced, right, with what are tribes' priorities, what are tribes' perspectives. We non-native scientists can't just be going data, 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 give it to us, right? Without an understanding of the consequences and without a very, very careful relationship building and trust building and doing this work in ways which are beneficial, not harmful. That is a very difficult road to follow. And I think more people are realizing, especially younger generations, are realizing how important that is. But we have a long way to go in our field still, I think.
So given that, I'm setting Jim up for something on purpose. Um, Given what Dr. Raff just said, there are a couple of problems in the promise of genomic medicine. One is the commercialization side, right? You might have, let's collect a bunch of data on this side for precision medicine, but on the commercialization side, you have to have a market. And if that market can't pay for it because they're on public assistance, or they can't pay for it because they're a very small population with a rare condition, they can't deliver that intervention to the people that they're promising it to. That's one. The other one are all the problems Dr. Raff and I had just laid out, is that you have big missing pockets of data that might not make it generalizable to other native populations in the Americas. So, and please, because your chapter 8 in with the Pima had mentioned some of that. So please.
Sure. Yeah. I think one thing that's interesting just to notice as a contrast between the sort of historical looking work of archaeology that Professor Raff is talking about, and then the biomedical, which is about trying to kind of go out and intervene in populations today. I think by putting them side by side in a conversation like this, you can see sort of where genomics gets purchased and where it doesn't get purchased. And so, I think the real advantage of genomics for historical sciences is, as Professor Raff said, it's this kind of historical log of change and relationships over time. Now, it doesn't sort of codify one answer where, right, if you get 3 genomes, suddenly now you've kind of solved the problem. And this isn't even unique to humans. There are still arguments about when the common ancestor between polar bears and grizzly bears, how far back that has to go. This is kind of just like phylogenetics and debates within phylogenetics about how you create these trees and where the forks are and how far back they go. But genomics is for decades, people have known that genomics can be a really powerful tool for tracing that history and noticing patterns of relationship and making inferences about how far back common ancestors were. And that's really fantastic. When you move to how do we intervene in the world today to sort of make the problems that people widely agree are problematic go away, think of things like diabetes, heart disease, cancers. That's where we start to see the limits of what this genomics is capable of, because the genomics that is giving us this historical story is not necessarily the same genes that are responsible for the health crises that are impacting communities. And so, by and large, what we're now finding when we're looking at the health impacts on communities, whether it's on populations or individuals, these are products of the environments that we live in. And no amount of gathering more and more genomic information is going to solve those problems, right? So you talked about the Pima Indian example, right? I mean, you can gather as much genomic information from that community as you want, but if you're ignoring the way that this particular tribal community has been given a horrific diet for decades and trying to explain diabetes without paying attention to that nutritional environment, you're just going to be missing the scene. And so I think that's just, unless you're talking about rare diseases with rare genetic causes, and some cancers, you're sort of looking for genomics to do stuff that it's not going to do the way it can help with the historical sciences.
Yeah. Um, we are 5 minutes left. Um, and I wanted to ask you. So, Lucilla Ono Machado, who used to be at UC San Diego, is now at Yale. She's a big data person, data security, all this kind of stuff. She is with, in 2021, she and two other researchers there got $11.7 million to start something called the Genetic and Social Determinants of Health Center for Admixture Science and Technology. The acronym is CAST. And so this is something that me and a lot of our colleagues at Native Bio have always, pushed against because back when it started with Cavalli Sforza and Bustamante and National Geographic and HDP, they only wanted to sample Europeans, Africans, and East Asians. They didn't want to sample people from the Americas because they thought the data was going to be too dirty, right?
Mm.
That too many indigenous people are too admixed, and it was not going to yield anything productive. It would be hard to figure out. But now, and just like a lot of the people that are part of Native Bio or Sing or Indigidata, where like we think that we're interesting for more reasons than one to be researched in this admixed condition. And a couple of things I have a problem with that is that we've been advocating for this forever, but instead they give the money to somebody that's not native, right? And the other two is when I graduated from the University of Washington, Seattle, Mexican had become a four-letter word, right? So Mexicans not recognized indigenous, even though 93% of Mexico has an indigenous ancestry. And they relabeled us as Latinos. And so this study, just like the San Antonio Heart Study, which is for Latinos, but most of those people are Mexican, right? Same thing for this study. Most of them people are Mexican, but they call them admixed or Latino populations. So now they're interesting, right? Because of the admixture, you have two very different populations that came together after being separated for 50,000 years, right? And they're looking for, again, these not only rare variants, but how they work epistatically, epigenetically. Like it's interesting now. So I'll start with Dr. Tabery. What do you think about this sort of, in order to get at these interesting questions, they have to sort of deprioritize that political history.
Yeah, I mean, I think partly what you're tracking is evolving notions of how we categorize people, right? Sort of who is indigenous and who's not, who's Latino and who's not, who's white and who's not, who's black and who's not. I mean, I think if there's something that modern evolutionary genomics has showed us in the last 60 or so years, it's these racial categories that we thought were fixed are far more complicated than anybody expected. And I think one benefit of that is you can sort of see the incredible diversity and relationships and do the kind of work that Professor Raff is doing that really kind of cuts down traditional ways of carving up humans, which oftentimes lends itself to sort of racist ideologies. But I also think a downside of that, which is I think what you're getting at, Joe, is it makes these categories pliable in ways that can be repurposed for new ends. And those new ends may not necessarily be aligned with the groups as they understand themselves and what they're seeking to get out of that kind of research. And so, right, you could sort of have a story like this where perhaps one sheen on it is, oh, look how we're sort of, updating in really progressive ways our understanding of these human populations, and yet the practical outcome of that is, the data is being used in new ways that people weren't sort of comfortable with, a kind of a categorical status that one group took to be very sort of important to them is now being sort of massaged away, and that's just I think a kind of a way that this fluidity of these categories can be abused.
Yeah, so I think, or what I like about anthropologists and archaeologists is they do have this long-term view of a genetic history, right? And they realize that people have been mixing for a long time, right? And so that original notion from uh, James Crick or James, I always get them mixed up. Who's which one?
Watson.
Watson, James Watson, Cavalli Sforza, and Bustamante about trying to keep these categories separate was wrong-headed. But we see that still today in NSF and NIH funding announcements, right? So the NIH um, has avoided admixed populations and want to target people they think are not mixed, like the Navajo Nation or something like that,
Mm,
because they don't really understand that history, while other folks like archaeologists and anthropologists, like they want to see what happened during those admixture events, like and
mm,
they actually test them statistically. Like does like Barbara McKnight at the UW, she showed us a study that's on Puerto Rico that said, yes, this is a triracial population. But over time, more and more of the variants that were original to the island are becoming at higher frequency because they must confer some sort of evolutionary benefit to living on that island. And then
mm,
myself, I did a paper with Dara Torgerson, and we also found that Mexican American populations over the last, I can't remember, what, 60 years have become more indigenous-like,
mm,
and we couldn't explain it away by migration or anything else. Like we looked at all kinds of days, we looked at all kinds of different ways, but for some reason, Mexican American populations, even if they've been here 4 generations, are not mixing, and
mm.
somehow they're conferring to themselves a more indigenous genotype. So anyway, with that, I'll ask Dr. Raff if there are any interesting questions in archaeology and anthropology about admixture.
Oh yeah, tons. I was just laughing because you mentioned Watson, and I literally just got back yesterday, day before yesterday, from a week at Cold Spring Harbor Laboratory. So, and we had a lot of conversations there about what is ancestry, what is genetic ancestry,
Mhm.
what is phylogenetic ancestry, like all these things. And really making sure that there's a clear distinction between these different uses of the term ancestry, because it can become so misunderstood and so many people are talking past one another, using this term in different ways. Cultural anthropologists use this in a very different way than geneticists do. Anthropologically oriented geneticists use this sometimes in different ways than more biologically oriented geneticists. And so I
Mhm.
think that is something really, really crucial that we all really make sure that we're clear about, is when we're talking about ancestry and descent, what are we talking about and what definition are we using? But, I agree with you, Joe, that, we've been talking about admixture and how interesting it is, the field of anthropological genetics, for a really long time, and along with you and your colleagues, and it's really funny to me that all of a sudden it's the thing that everybody wants to look at.
Mm.
But a number of really great geneticists in our field have been for decades talking about, look, if you're going to sample Native American populations that are living, you cannot just restrict sampling and study to those who have ancestry from pre-contact populations, right? Because who is indigenous today in these populations is people with a wide variety of genetic ancestries. And that's
Mhm.
really important. It's really meaningful to recognize the diversity of histories, the diversity of ancestries that we see, and to look at it, in its full context. And so, my research group, we're doing that. We're looking at contemporary peoples and their many ancestries and how admixture with Europeans and other populations have really affected and impacted these groups, and over time. So I don't know that I have much to contribute there. I'm just saying, yes, these are important questions, and there is a lot there that's really interesting and really important to look at.
Well, and I think anthropology and archaeology also talk about definitions, like especially gender roles and other kinds of things. Like what creates a warrior? Is a warrior a gender, or is warrior the person who does the work, right? And then
Mm,
you look through the fossil record or the archaeological record to look at some of those questions. But the reason why I was interested generally, though, because we have these conflicting things. We had them during COVID, whether the Neanderthal was protective or not protective during COVID, like
mm,
just all this crazy stuff. And we've had for a long time, Esteban Bouchard came up with this large asthma study and said that across Latinos, those with more native ancestry were protected from asthma. But then there's another asthma study with people from the Northern Plains that says the more native ancestry, the more you're susceptible. So there's
mm.
something in there, right? And the same thing at uh, the border. Dr. Tabery had in his book about the Pima, essentializing all natives as having type 2 diabetes when that's not true, because there was a study that said people on the north side of the border had high type 2 diabetes, but people on the south side of the border who were also obese had less type 2 diabetes. So they're genetically identical, but there's something in there, socioeconomic, political, whatever, that's mitigating the genomics. So, Dr. Tabery.
Yeah, I mean, the lesson I draw from that is if you keep the air clean, it doesn't matter what your genes have to do with asthma. You're going to be in pretty good shape. If you keep people eating healthy diets, and sort of give them opportunities to live active, healthy lives, um, regardless of what the genomics say, diabetes is going to go down. And so there's always stuff that's getting sorted out at the genomic level, but at least on the health side, not so much on the sort of historical side with what Professor Raff does, at least on the health side, if what you want to do is see rates of asthma or diabetes or heart disease or cancer, any of those things go down, carving up subpopulations and trying to sort of figure out which genetic interventions to do in which group is going to be far less efficient and successful and cost effective than just making the environment for all those people healthier.
So we're at the end. I want to thank you both for being on the inaugural presentation of Love Digenous Genomics Discussions, which is what I'm calling it for now. And I don't know, you probably have a minute each for any final thoughts.
I just want to say thanks for having us on, Joe, and Dr. Tabery. This was a really great discussion. Always good to chat with you.
I agree. And, I think I would encourage listeners, viewers to really take a hard look at Native Biodata Consortium, because I think it's really leading the way as there is growing angst about how genomic information is being used and commodified and taken advantage of. The work that you're doing, focusing on indigenous genomics, I think really has the potential to be far more revolutionary, because it's paving the way for thinking about how to access, control, use, donate this data differently. And we're at a time where thinking about this stuff differently is really in short supply and in high need. So thank you for the work that you're doing.
Well, thank you both for being on my show. Thank you.